So in our notes, if you remember last time we were evaluating some of those trig functions like we were just doing on the Kahoot. And so we're going to use that idea to now solve trig equations. So here we go. And so these are just algebraic equations like we've been doing, except it involves some of that sine, cosine, tangent stuff. So for example, if we had 2 sine x, which is 2 times the sine of x, plus the square root of 2 is equal to 0. And we want to solve that for x. We want to know what values can we plug in for x so that that's a true statement. For the problems that we're doing, for all the problems that I'm going to do 4 or 5 of them, we are only going to solve for one loop around the unit circle. So that means that our x would be greater than or equal to 0 or less than 2 pi. Okay. So because you can keep going around the unit circle and get an infinite amount of answers. We just want this for one loop around the unit circle. We're going to use our basic algebra. If we want to get this variable by itself, first thing we do is move that guy to the other side. So I have 2 sine x is equal to the opposite of the root square root of 2. And then divide by 2. So I have the sine of x is equal the opposite of root 2 over 2. I'm done with the algebra. I'm ready to give my answer. And the reason I'm ready to give my answer is because I know the first quadrant of the unit circle, which I'm going to draw right over here. And I would encourage you guys to draw it. Now, some of you are sitting out there like, why does he keep drawing this thing? Yes, I do know it, but I keep drawing it because I'm hoping you guys do, because we got to know this at the tip of our tongue here. This is pi over 6. This is pi over 4. This is pi over 3. And our coordinates are as easy as 1, 2, 3. So if I just wrote this down each time, I'm not going to do it for every problem because I only need to write it down one time. I have the entire first quadrant, and I'm going to go back to my equation. So I'll give you guys a second to catch up. But what we're looking at here is we want to know all places where the sine is negative root 2 over 2. Remember, sine is the y value. I know that y values are negative down here in the third and fourth quadrant. I know that my reference angle is pi over 4. So what I need to have is I need to have pi over 4, but down here in the third quadrant and down here in the fourth quadrant. So that pi over 4 reference angle in the third quadrant is going to be 5 pi over 4. And in the fourth quadrant is 7 pi over 4. Those are my two solutions. Okay, so I obviously got to be real familiar with, where is the sine equal to negative root 2 over 2? And that's why we've been practicing evaluating these so often. Okay, any questions on the first one? All right, I'm going to keep rolling then unless you guys stop me. So remember, I can't see all of you, but I can certainly hear you. So just yell out your questions if you have them. Let's try another one here. We have 2 cosine x plus 1 is equal to 0. All right, 2 cosine x plus 1 is equal to 0. So algebraically, I want to get the trig part by itself. So I'll move the 1 over by subtracting 1 from both sides. So I have 2 cosine x is equal to -1. And so cosine of x is equal to -1/2. All right, now I'm going to refer back to my unit circle. Where is the cosine -1/2? Well, I know cosine are the x values. X values are negative in the second and third quadrant. Cosine being the x, my reference angle is pi over 3. So I need pi over 3 in the second quadrant and in the third quadrant. And so in the second quadrant, that would be 2 pi over 3. And down here in the third quadrant, it would be 4 pi over 3. Those are my two answers. So x equals 2 pi over 3 and 4 pi over 3. All right, next one. 4 sine squared x minus 1 is equal to 0. So I want to get the trig part by itself. I want to get the sine squared by itself. So I'm going to move the 1 over and then divide by 4. So I'd get sine squared x is equal to 1/4. So I skipped a step in there, but you guys loved skipping steps, so I figured I'd join in. But I solved it for sine squared. I have to solve it for sine. So I'm going to take the square root of both sides. So if you're nodding off, don't miss this. Because when I take the square root of the left side, I get the sine of x. If I take the square root of the right side, the square root of 1/4 is plus or minus the square root of 1, which is 1, over the square root of 4, which is 2. I still have one more step, but I want to say that part again. I took the square root of 1/4, and when I take the square root, I get plus or minus, and then the square root of the top is 1, and the square root of the bottom is, I'm sorry, not square root of 2, my mistake. It's just 2. The square root of 4 is 2, not the square root of 2. Okay, so I just want to find where is the sign, either positive 1/2 or negative 1/2. Well, the sign is the y value. The y value is 1/2 here. It's also going to be 1/2 in the second quadrant because it's the y value. It will be negative 1/2 in the third quadrant and negative 1/2 in the fourth quadrant. So I actually have 4 answers. With a reference angle of pi over 6, I have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So x is going to equal pi over 6, 5 pi over 6, that's our second quadrant, 7 pi over 6, that's in the third quadrant, and 11 pi over 6 is in the fourth quadrant. All right, I'm going to do one more, and then I'm going to have you guys practice on your own. So please make sure you speak up if you guys have any questions. All right, for our last one, how about the square root of 3? We'll make this an ugly looking one. Square root of 3 times the tangent of x is equal to 1. So the algebra is pretty easy here. The algebra, I'm just going to divide both sides by root 3. So tan x is 1 over root 3. Okay, or I could rationalize that to root 3 over 3. But what I want to do is really use that unit circle and figure out where's the tangent 1 over root 3. So tangent is sine over cosine. So if I took the sine of 1/2 over the cosine of root 3 over 2, remember that little shortcut I showed you where the 2's will cancel? And we're left with 1 over root 3. And so pi over 6 is where the tangent of x is equal to 1 over root 3. But there's another place. Because remember, tangent is positive in the first quadrant and in the third quadrant. So pi over 6 is my reference angle. Its comrade over here in the third quadrant is 7 pi over 6. And so my solutions are pi over 6 and 7 pi over 6. So x equals pi over 6 and 7 pi over 6.
Wait, is it 7 pi over 6 because the negatives cancel?
Exactly. Yes. Good question. I didn't even miss who that was, but whoever it was, that was a great question. Because you have a negative over a negative, which is a positive. So it's good to remember that the tangent is positive in the first and third quadrants. And it's also negative in the second and fourth quadrants, by the way. So
I have a question. Do we need to rationalize it when we're doing it like this or no?
yeah, that's a good question. If we're evaluating, yes, we want to rationalize it if we're evaluating. But if we're solving, like in this case, you don't necessarily need to rationalize that because remember, that's not our answer. So to answer your question, answers need to be rationalized. This is just a step to getting our answers. So therefore, we didn't need to rationalize that. All right, great questions. Anything else? All right, I'm going to go over the class kick here. So let's go up to the first problem. You guys did really well with the algebra part. You know, we move this guy over and divide by 2. And so we get the sine of x is equal to root 3 over 2. But you know what I didn't see enough of? I didn't see a lot of this. I didn't see people drawing that first quadrant and writing out those values. And I just think that it would be a good idea to do that over and over and over again. Hopefully I am modeling good behavior here, right? So 1, 2, 3 to get those started. And the reason I'm writing that is because I'm going to use this to solve every problem that we do. So it's worth my time. I don't want to do it for every problem, but if I'm going to get 4 problems out of it, I think it's worth my time. So now I want to know where is the sine root 3 over 2. The sine is the y value. Y values are positive in the first and second quadrant. So that would be our reference angle is pi over 3. And then over here in the second quadrant would also be at 2 pi over 3. So those are our two answers. X is equal to pi over 3 and 2 pi over 3. Okay, next. This is where we have one of those squared problems. So thank you that we changed this to a minus from a plus. And so if I move the 1 over and divide by 4, I have cosine squared x is equal to 1/4. And when we take the square root of both sides, I get the cosine of x is equal to plus or minus 1/2. Don't forget it's plus or minus. So that's going to give me 4 answers because cosine is positive 1/2 in the first and fourth quadrants because it's the x value, and it's negative 1/2 in the second and third quadrants because it's the x value. So my reference angle is pi over 3. So it's going to be pi over 3, 2 pi over 3, that would be in the second quadrant, 4 pi over 3, that's in the third quadrant, and 5 pi over 3. Next, I'll move the -3 over and divide by the 4. So I have sine squared x is equal to 3/4. Take the square root of both sides, and the sine of x is √3 over 2. But do not forget plus or minus. So when you're taking that square root, and that's a big deal, you know, especially when you're working your delta math, it's not going to mark it correct if you only write 2 answers instead of 4 answers, right? So now we want to know where is the sine, which is the y value, √3 over 2, and that is here. And it also can be in the second quadrant, and in the third quadrant, and in the fourth quadrant. So our answers happen to be the same as the one before. It's pi over 3 is our reference angle. And so our answers are pi over 3, 2 pi over 3 in the second quadrant, 4 pi over 3 in the third quadrant, and 5 pi over 3 in the fourth quadrant. All right, we are rolling. Any questions on any of those before I do the last one? Okay, so on the last one, I'll move the 1 over, and we have cosine squared x is equal to 1. And when you take the square root of both sides, the square root of 1 is going to be 1. But remember, plus or minus 1, right? So now where is the cosine, which is the x value, positive 1 or negative 1? Well, the x values are -1 over here at pi and +1 over here at 0 and at 2 pi. But this is a little trick. And don't forget, we only want values greater than or equal to 0 or less than 2 pi. So that means we're only going to have 2 answers. Okay, this answer is pi, that's in between those two. But when we find this answer, I'm just going to use 0, and I am not going to use 2 pi because we want it to be less than 2 pi, not less than or equal to. And so our answers are only pi and 0. So I probably should write those. Oops, I forgot my x there. Probably should write those as 0 and pi, right?